Welcome to Part 2, Processes and Threading. Today's agenda, we are going to encapsulate our code in a class. We are going to create a process for parallel code execution, a simple user interface, and finally we're going to show our FPS on the computer vision. So if you're enjoying this, please consider liking and subscribing. I would appreciate it. Okay, so let's get started. Today we're going to be making some very big jumps forward in our program here. We're going to be introducing multiprocessing. This is going to allow us to create processes, which will allow us to execute code in parallel. In our previous version of this code, we would be stuck in that while loop showing that image over and over again. We'd never be able to execute any other code till we quit out of that loop. Well, today we're going to introduce how we can start that loop and we can start other loops or start executing other code so that our AI can capture the screen, show the screen, and execute other code at the same time. So let me show you a really quick demo of what we're going to be working towards today. So we're going to be creating a menu, and I'll be introducing how to add some color, some bling to our command line. This is pretty simple stuff. We'll be starting a process, so if I hit R or run, it will start that process. So I have my computer vision. We're also going to be, I'll also be showing how to add some things to the computer vision. So like for example, today I'm displaying the FPS in the top left-hand corner. The typical performance of my unit when I'm not recording is around 50 to 60 frames per second. But while I'm recording for you guys, the frame rate's a lot lower since I'm also capturing the screen in another program. But that shows you that. And then we can also do, so I'll show you the parallel code execution. So if I try to run again, I have a warning here. Warning, capture process is already running, so it won't let me start another process. I can type in stop. It'll now stop that process, so that window is closed. I can run it again. So you can see that even though this loop is running and that this code is executing and I'm getting this live screen capture, other code can still be executed. Other code is still working. So there's a loop here checking for my user input. So I can also quit out of the program. So that's what we're going to be working towards today. And it seems maybe like a small step, but introducing the multiprocessing, creating processes, working in parallel, this is a very big jump. And it's also very useful to apply to all of your Python programs. So let's get started. Okay, so let's get started. So the first thing we're going to want to do is we're going to want to import multiprocessing. Multiprocessing is going to allow us to create processes so that we can run code in parallel. And next, what we want to do is, right now we have this, kind of script that gets stuck in this while loop, and that's a little bit problematic for us. So let's encapsulate this entire thing into a class called Screen Capture Agent. So let me create a class called Screen Capture Agent. And I'm going to tab over all of this code. So we'll have to refactor this in a minute, but let's put all of this in the class for right now. So now I have a class with all of this stuff. So the first thing we want to do when we have this class is we're going to have to define our initialization, our init function. So let's look at what we would want in there, and we can tab it over. So we definitely want to initialize our width and our height, and we can print that out at that time. We have our image here. So I'm going to actually add some variables. So instead of having image, we're going to have self.image, since this will be part of the class. We're going to also have a few extra things that we're going to be working with in a moment. So we're going to have self.captureProcess. This is where we're going to store the process that we are going to create, since we're going to be working with multiprocessing. We're going to want to be able to access this process from inside and outside of the class to turn it on and off, for example. We're going to have self.fps. This is where we're going to store our frames per second so that it can be worked with other, work with other classes and objects so that we can display that, for example. And then I have self.enable CV meaning computer vision preview, and I have that as true. And this is kind of a placeholder that we can work with in the future. This is where we could turn on and off our computer vision, meaning we may not want to display the window showing the computer vision. We may want to disable that so it's not taking up our computer resources, for example. Okay, so we're still going to want our width and our height, but let's save this as a class variable instead. So we have self.width, self.height. We're going to have to update this line of code here so that we're using self.width, self.height. And we no longer need image since we will be storing in self.image. And let's tab over monitor. We'll say self.monitor. So we'll save this as a class variable. And let's add selfs to these. So we have self.width, self.height. Okay, so now all this stuff's part of the class. That looks good. And then now we get down to this code. So this is going to be our loop that's going to be capturing the screen. And we don't want this to be, we could put this in the init function, then it would start upon creation, but I think it's better to make this a little more flexible and versatile. We can instantiate this agent, so we can instantiate it so we can set it all up, but then this code we can turn it on and off. So that might be a better way to approach this. So if we create a separate function here, we can define a class function capture screen, pass in self. We can then tab all this stuff over into that function. So now I have a class function called capture screen that I can use as my process. I can turn this into a process in a moment, and we'll be able to turn this off. So we can create a screen capture agent, and we can tell him to turn on and off his screen capture process since we've defined that as a function. So I'm going to rename this T0. This is what we're using to calculate our frames per second. I'm just going to rename this to make it a little bit more clear. So we'll call this FPS underscore report time. So basically, when was the last time we reported the frames per second? We'll initialize that as now. And we'll also create a FPS underscore report delay equals 5 for 5 seconds. This will be a delay that we're going to use for how often we're going to update the frames per second on the screen. We don't want it to constantly be updating so that it's kind of a mess. This will just let us create a delay and kind of average it out over 5 seconds. Okay, this code will remain the same, so we're still going to use MSS. We're still going to use this image grab function, but we are going to have to make sure that we're working with our class variables and not not creating a new one called image. So we want to use self.image equals self.monitor since we need to pull that out. And this self.image is going to be a NumPy array created from self.image. Okay. And then here's where I'm going to implement in the future this enable CV preview. So we can say here if enable if self.enable CV preview. So if that's enabled, we can create a small version of the image and we can show it. Right now, we're not going to even turn this off in any way. This is just kind of a placeholder, but you understand the functionality. It'll be convenient to be able to turn that off in the future. And we're going to want to use self.image to create this small version, and we'll show it. We're no longer going to be using this cv.wait key. As I showed you in the preview, we're going to be turning on and turning off this as a process. So no longer is this going to become a loop that we are going to break with the key. So let's delete this code, but make sure we keep the CV wait key 1. And the reason is, if we don't have that, and let's put that in this if statement, if we don't have that, as I mentioned before, this won't actually display for us. So we want to add that 1 millisecond delay to give it time to actually show the computer vision if our computer vision is enabled. So we want to keep that just for the display purposes here. But we no longer need to use that as a check to break out of this loop, as I'll show you momentarily once we create a process from this. And then let's just refactor this code a little bit here. So we rename T0, so our elapsed time is going to be time.time minus our FPS underscore report time. And we can say if our elapsed time is greater than or equal to our FPS report delay. Then we want to print out our frames per second. So what we'll do is we'll say self.fps because we want to store frames per second now in our class. We'll say self.fps equals, so how many frames did we do? So we'll say n frames divided by our elapsed time. This will give us frames per second. So every 5 seconds, this code will run every 5 seconds approximately, after it's greater than or equal to 5 seconds. It will calculate the average FPS because we're taking the number of frames and the total elapsed time, so that'll kind of average it out. We'll be able to store it here so that other applications or other processes can utilize that. And we can also print it to the console here. So we need to say self.fps now. So we can print this to the console. And when we do this, because we've just reported this, you have to remember that we have to reset our frame count. If we don't reset our frame count in our time, then that won't work. So we'll say n frames equals 0. We'll say our elapsed time is equal to time.time. Not elapsed time, I'm sorry. Our FPS report time is equal to time.time. So that when we run this code every 5 seconds, we're going to calculate. So again, we're going to run this every 5 seconds. When it runs, we're going to calculate the frames per second by taking the elapsed time since the previous run, which will be close to 5 seconds, maybe a little bit longer. It will then say, okay, how many frames ran in that period of time divided by that elapsed time gives us frames per second, stores that into our class variable. We're then going to print that, and then we're going to reset. Since this will add 1 frame at the end of this code execution, we're going to reset this back to 0 so that we go back to 1 frame here, and we're going to reset our report time to now so that that clock can start over. So that's kind of how we're going to do that. Okay, next I'm going to delete the CV destroy all windows for now. And so next we're going to create kind of our main entry point into the program. So we're going to create a if underscore name equals underscore underscore main underscore underscore. This will be our program entry point. So the first thing I want to do, let's think about what we want to do with this code. First, we're going to want to print our menu. If you remember, we're going to want to print to the user what they need to do. We're going to, that's number 1. Next, we're going to get user input. Okay. Then if the user, based on what the user inputs, we're either going to start, stop, quit. So we're going to make a decision on what to do. And so let's look at these steps. So first we have to print the menu. So let's create a function. And this doesn't have to be part of the class. This can just be a standalone function. And we'll define this and we'll call this print menu. And let's give the user a couple different options as I did. So we'll say print, and let's make this a formatted string. And I'll explain why in a moment. We can say command menu. So this is going to be our commands, print, formatted string, and we'll say tab R. So I'm going to put a tab in there so that it pushes this over just so it's a little easier for the user to see. R-run, and then we'll say dash tab again, and then we'll say start screen capture. Okay, and then we'll say print formatted string. We'll do a tab s dash stop. We'll do another tab and we'll say stop screen capture. So these are just kind of shortcut keys. We're going to tell the user what to press. Whoops, let me fix this. Get rid of that star. And then we'll have a print. We'll do another formatted string here. And we'll say tab q dash quit. And then we'll do another tab and we'll say, whoops, can't see. And then we'll do another tab and we'll say quit the program. Okay. So in our main function, let's do this. So when we run this code, first thing we'll do is we're going to print the menu. So let's just see how that menu's looking. Okay, so you can see that I have a command menu here. I have RSQ. I tabbed that over. It looks kind of nice. I have run, stop, quit. So what we're trying to tell the user is they can either just press the R key or they can type in run. And then I'll tab this over one more time to make this flush with these other ones. So we have start, stop, and quit. So that's pretty good. So let me add another tab here just to kind of clean that up so it looks a little bit nicer. So that's going to be our command menu. So before we go on, let me show you how to add some color, because I think that makes a big difference, especially if you're going to make CLI programs. It can really make the user experience better. So we're going to use ASCII escape keys to do this. So I'm going to create a class that's just going to be used for putting in the codes that I'm going to define. You can look up on the internet all the different codes that you can use for different colors and highlighting and stuff. There's lots of options. We're just going to make a couple real quick here that we're going to use just to give you the idea on how it can be done. So we're going to create a class, and I'm just going to call this bcolors, and we're just going to define a couple of things in it. So we're going to define pink, and it's going to be, you're going to want to use this code here, \033 bracket 95M. Okay. We're going to do a cyan, and like I said, you can look up these codes online. You can see there's many more. These are the ones that we're just going to demonstrate for today. So I'm going to do, and this is a square bracket 94M. Okay, blue. We're going to do a green one. And this should work on Windows, Linux, and Mac. I think Windows is the pickiest, so you might have to investigate any tricks on Windows. That's the most tricky one, but it should work on every platform. We're just going to define a couple of colors here. And then this end C, this is going to take us back to the default. So this is kind of the way to end the color. So let me show you how to use this. So this is why we used a formatted string to make this very simple. So we're going to use one of these colors, and then we're going to use NC to get back to a normal. So if I want to make all of command menu a color, like let's say I want to make that cyan, I can use the formatted string. So I'm going to put my curly brackets, and I'm going to use that class. I'm just going to call bcolors.cyan. And then where I want the color to stop and go back to normal, I'm going to again use curly brackets, and I'm going to call bcolors.end. See, end color. And let me print that and see how that looks. So there you go. You can see command menu is now cyan. Let me clear my terminal. It's kind of a mess. And there you go. So now we have a cyan command menu. That looks a lot better. And for run, maybe what we can do is we can put a bracket here, and let's use bcolors.green. So run is green to start it. That kind of makes sense. And for stop, we might want to make that red. So we'll say bcolors.red. And we'll end it on this side. And for quit, we'll just leave that white. Let's see how that looks. Oops, I must have missed one of my end. Let's see. Oh, I have red here, not end. So I did not end it. And here I have green, and I didn't end it. There we go. So you got to put the start and the finish. You want to finish with the NC code if you want to go back to the standard color. So there we go. Let me clear that. Let me run that. So there you go. It looks pretty good. We have a cyan command menu, green run, red stop. So that's how we can add some color, some flair, make this look a little bit more professional. And I haven't defined any of these functions yet. So that's our print menu. So now what we got to do is we want to check the user's input so we can make decisions. So and we want to continuously do that. So what we're going to do is we're going to put this in a while true loop. And let's tab this over. So every time this while loop runs, we're going to reprint the menu for the user so that no matter what they type in, if they make a mistake, we can loop back to this. So that's kind of a useful trick. And we can say user input equals input. And then what we want to do is we want to process this a little bit. So we'll do a dot strip. This will remove white space characters like the return carriage. And then let's do a dot lower. What this will do is if they type in a capital R, we can convert that to a lowercase so we can do all of our comparisons with lowercase. And then let's do if user input equals quit or user input equals Q. So they can type Q or quit. We will break this loop and quit the program. Oops. And we can do an elif user input equals run or user input equals R. I'll put a pass in here for now. That's where we're going to do our run code in a minute. Elif user input equals stop or user input equals S. This is where we're going to put in our stop code. And what we can do is we can do else. So if they type in anything else, for now we have no other. If we add more things, we can add more options here. But right now, if they type in anything else, we'll just do a print. And let's do an F string. Let's say, and let's put this in brackets. Let's put this in red since we got our colors now. And let's do red. We can say error. And let's end it. We'll end that color. And we'll say error, invalid selection. And let's run this, see how this looks real quick. All right, so if I press Q, it should quit. It does, good. And if I run it again, and I choose something that's not a choice, there you go, I get error, invalid selection, and I get the menu back again. So that looks good. So it looks like our basic loop for input is working quite well. Okay, let me get rid of this. We don't need that anymore. So then let's do this. Let's print done when this exits so that we know the program is closed. So next we want to implement our threads, our processes, I should say. So this is where things are going to get kind of interesting. So when we press the R key, we are going to want to create a process. So let's do this. Let's get rid of this pass. We don't need this anymore as a placeholder. So what we're going to do is we're going to, well, first, actually, I'm sorry, before we do anything, we need to instantiate our screen capture agent. So when we start this main function, the very first thing we're going to want to do is we're going to want to say screen capture. We'll say screen agent equals screen capture agent. So we need to instantiate this class first before we start turning things on and off. So before even this while loop, let's create a screen agent. Okay, so now when a user presses the R key, we want to start a process, and that process is going to start this capture screen method. So how are we going to do that? Well, this is pretty simple. What we're going to do is we're going to do screen agent dot capture process, because when we start this process, I want to store it here so it's easy to get back to it later to turn it on, off, for example. So we're going to store that there. So we want to say screen agent dot capture process equals multiprocessing dot process. So we're going to create a process, and inside this process we have to put some parameters. So the first parameter is the target. The target is going to be the target function that is going to be run by this process, the entry point. So in our case, we want this process to run capture screen so that it's continuously capturing the screen, and it's going to be in this while loop. We want this process to enter here, get into this while loop, and just keep running this while loop for us over and over again. That's the process we're trying to create. So the process is going to be screen agent, because remember that that function is part of screen agent dot capture screen dot capture, not that, capture screen. Now when we put that function in, be very careful. Do not put it in do not put the parentheses operator there. If you do this, it's not going to work properly, because that will return the result of running capture screen, which is not what we want. We want to pass the actual function as the target. So right now we're passing the function. We're not passing the result of running that function. So make sure you do not include the parentheses here. Okay, that's our target. Next, we want to include any arguments that should be passed into that. In our case, we do not want to pass any arguments, because this this function does not take any arguments other than self from the class. So if it did have other arguments like A, B, we would add A, B here, but we do not have that, so we do not need to do that. Okay, next we can give this process a name so that it's easy to identify. So we can call this the screen capture process. And we can close that out. So that's going to create a process. It's going to store that here so that we can access that later by calling screen agent.capture process. And that's going to create it, but that's not going to start it. So immediately after creating that, when we hit run, we want to create this process, and then we want to run it. So what we'll do is we'll call screen agent.capture process, since that's what we called it, and then we'll say .start. And that will start the process. So let's try that right now. Okay, so I'm going to hit run. And there we go. It started that process. And we can see that the process is it's a process, and that we're not stuck in that loop, because I can still quit this program. Now, the program is quit, but this process is still running, because I haven't told that process to quit. So we have to tell that process to terminate. I've quit my program, and you can see it says done, which means that this loop broke and I got down to here, but that process is still running. So that shows you how it's running in parallel. But we have not terminated the process because we never told that process to stop. So I'm going to kill that, hard kill that. So next we want to implement a terminate command on that process so that it closes properly. So when we go to our quit command here, before we break out of this loop, we want to terminate that process. So we can call screen underscore agent dot capture process dot terminate, and this will terminate the process. So I'm going to run that, and now if I press quit, you can see that I get done again, but now I get back to my terminal because that process has quit. So I am no longer stuck in that process. Very, very easy to do. Now we have a couple of problems though, small problems if we were to try to debug this thing. First problem is that the way this code's written right now, we could terminate this without this existing. So because we're initializing this to none. So what we want to do is we want to make sure that that process is running before we try to terminate it, right? So what we can do is we can say if screen agent.capture process is not none, then do this. So if it's not none, do this. Okay? So now if I run this and I hit Q, I never created the process, but it's not going to throw an error because that is none. It's not going to try to terminate it. So that's one problem solved. Another problem that we have is that it's possible to start the process more than one time. So what we can do is, in our run command, we can say if screen agent dot capture process is none, or let's do this, if it is not none. So that means if a process exists, because we've started one before, then we can print. Let's copy our print line down here. We can print, and let's change this to yellow because it's kind of a warning. We can print warning, and we can say capture process already running. This way it won't start it again, and then what we'll do is we'll continue. So what this is going to do is, if we hit run key and the capture process is not none because we've already created one before, it will give us this warning message, and then it will run this continue keyword, which will tell the while loop to do the next iteration of the while loop. So we will not start a second process and overwrite the previous process that's running. So let's try that. So if I hit run, I create a process. If I hit run again, I get warning, capture process is already running, and it did not try to start another one. And if I hit quit, it kills that process. So that's looking pretty good. Oops. Okay, so next we want to implement our stop. So this is going to be quite similar. So we're going to say if screen agent dot capture process is none. So if it's none, we have nothing to stop. So we can copy this warning, and we can say warning, capture process we can say capture process is not running. So you're trying to stop a process that's not running. And we can continue. And if it is running, then we want to do screen agent dot capture process dot terminate. We want to terminate that process. Then we want to set screen agent dot capture process to none. And the reason is, once we've terminated that, we don't really need it anymore. We can set it to none, and that will allow us to hit R and run it again. So we should be able to turn this on and off now. When we turn it on, it's going to put it in there. It's going to get rid of this none. It's going to put the capture process, it's going to put the process in there. When we stop it, it's going to terminate that process and then set that back to none, so that these other commands here know that they can start or create another process. So let's try it out. All right, so I'm going to try to stop. You see I get a warning. It's not running. I'm going to try to run. It's running. I'm going to try to run again. Get a warning. Capture process is already running. I just got an FPS update. And then I'm going to hit stop. And it should stop. And there it goes. So it stopped that process. And I should be able to run it again. So I can run it. I can stop it. I can run it. I can stop it. And I can quit. Okay, so we now have a process that's capturing the screen, which means we'll be able to create other processes like health monitoring, movement, anything else that you want to do for your AI. So this is actually a pretty huge step in the process. So the last thing I want to do today is I just want to add a little bit of OpenCV stuff to kind of reinforce that. So we're going to do one thing that's kind of cool. We're going to add the frames per second display to our OpenCV capture. So it's kind of going to start to implement some visualization stuff. So let's go back up to here to where we're creating our preview image. And we have this small image here that we are creating from scaling down the screenshot. So what I want to do is I want to add some text. So what we can do is we can say if self.fps, this is our frames per second, is none, then we'll say fps text is an empty string, because what we don't want to do is we don't want to try to set this text from a none type. That could cause an error. So that way, if at any point in time this is none because maybe it hasn't been initialized yet or hasn't been updated yet, we can just say don't show anything. And then we can say otherwise our fps text is going to equal, and let's do a formatted string here, fps, and then we can say self.fps, and we can format that as a 2-digit float. Okay, so now we have our FPS text, and what we want to do is we want to add that to that small image. So here's how we do that. OpenCV has a command called put text, so we'll use cv.putText, and this is going to take a few parameters. So the first parameter is the image that we want to add it to, so we want to add it to our small, because that's what we're going to be displaying. Next is our text, so we're going to add our FPS text. Okay, that's easy. The next thing we want to do is we want to put the coordinates of this text box, you can think of it as, and it's the bottom left-hand quarter. So in our case, I was experimenting a little bit, but we'll just use 2550. You can experiment and try other coordinates if you want. This is just like moving a text box around in a window. Okay, next we want to use a font face. So you can look at OpenCV's documentation on the different types of fonts. So we'll do cv.font, and you could try any one of these, but I like the duplex font. Okay, next is a scale. We'll just use a scale of 1. Again, you can experiment with this. Okay, next is color. So this is going to be a BGR color. So if you wanted blue, you do 25500. But in our case, I like to use a magenta to kind of make it pop. So we'll do 255 So then we have B and R mixed together to get that kind of magenta. We'll do a thickness of 1. This is, again, thickness of the line that you can show. And then line type, we'll do cv.line, AA's anti-aliasing, and we'll save that. So let's run this now and we'll see what we get. So we should see upon the next update our frames per second display in the top left-hand corner. There you go. So you can see that I'm getting 29 frames per second right now. Again, I'm videoing, so it's a little bit slower. Hopefully you're getting a better performance. But this is how we can start to add visualization to our application. So again, today was a pretty big tutorial. We covered a lot of topics. We covered processes. We covered a little bit of visualization here. So in the next tutorial, we'll start to implement even more functions. So thank you so much for sticking along with me on this. It's been very fun. If you enjoyed this content, please like and subscribe to my channel. That would be really appreciated by me. And I'd love to hear your feedback on this project and get your comments on what you'd like to see and what you've done with this project. So thank you, and I'll see you in the next video. Have a great day.